hello everyone. Welcome to our awesome webinar. We are the Operations Research Society of South Africa, and thank you for joining us. And hopefully load shedding hasn't been too much of a problem. It seems to always hit when we're doing these webinars, so maybe just bad luck. But yeah, thank you for joining, and thank you, Esmarie, for speaking to us today. Super excited for your talk. I'm Jess. Me and a team of people organize events for ORSA. So we do quite a few of these webinars. We also do some in-person socials. We have AMA, or Ask Me Anything, or really Ask Us Anything, coming up in 2 weeks' time. That would be excited for people to join. That is on the ORSA website if you want to check it out. Yeah, there we'll be providing some information, and people can ask whatever questions they have. For example, you may ask about the conference, or analytics certifications, how to use and register on the website, how our events work, how our meetups work, all of that kind of thing. But yeah, check out the website. On the website, you'll also see the registration for our conference, which is happening in September, which is really awesome. So yeah, check that out. If you have any feedback or ideas about the events, or questions, comments in general, please feel free to email me at events@orsa. And yeah, would love feedback or thoughts. If you have questions about ORSA in general, there's also our secretary, which you can email Lishan, and her address is also on the page at the moment. Cool. So just please make sure you're muted. Would love if you would ask questions. As Maria said, you can interrupt her if you like, so please go ahead. Otherwise, you can put them in the chat and we can ask them at the end. Cool. Okay. With that, let me introduce Esmarie. So Esmarie completed her undergraduate degree in industrial engineering at Stellenbosch University in 2011. She discovered operations research during the course of her undergraduate degree, and then went on to complete her master's degree in industrial engineering, also at Stellenbosch, where she focused on multi-objective meta-heuristics. She is currently managing York Timber's recently established analytics solutions team, working across various domains of the forestry and forest product supply chain. Thank you, Esmarie, and over to you.
Thank you, Jess. Okay. I'm going a bit into the adjacent rooms. Let's start. Okay. Good evening, everyone. Thank you very much for attending this evening. So what we're going to be looking at this evening is common operations research applications in the forestry and forest product supply chain. So I think I want to start off by saying that I'm aiming this talk very much as at an operations research audience. So I might be like repeating very basic forestry concepts, which might be like not so interesting to the forestry people joining, but hopefully it makes the conversation easier to follow for other people. So I think one of the first things that I kind of think of when I think of forestry is that it's kind of this crazy industry that's a bit obscure in some ways in South Africa. It's not like very well understood by the vast majority of people I come across. And yet it's an industry that offers us so many things and renewably. It offers us construction timber. It offers us like paper and packaging. It offers fabrics and amazing architecture. So to name like a few, there's so many applications of timber. So I think it's a really like interesting industry just for the products that can be made from wood and the fact that it can be made sustainably. So in that sense, I think it would be awesome if more people knew more about forestry in general. Then, as Jess said, I manage York Timber's analytics solutions team. It's a team that's been recently started, and we have the honor of working across like a wide range of the supply chain at the company. It's an integrated forestry company, and that means effectively that we have our own plantations that we manage. We also have logistics in-house, and then we have manufacturing plants where we manufacture primarily structural timber, and plywood. So you would find our products in shops with our York Timbers logo on it. Then I think for tonight, I'm going to look at a few things. I'm going to introduce the forestry supply chain, just at like a high level to guide the talk. And then from there on, I'm going to look at a few like very common supply chain planning problems within the supply chain. And these problems are not new problems, but they are, they're very well studied and they're classic problems. So I think they kind of give a good overview of where key decision points are and what people are interested in optimizing. Then from there, I have like a little bit of fun reading if you are an OR geek. And then finally, some things that we can look out for in forestry in terms of advances in the optimization or operations research space. Cool. So I think to start off, at like a very basic high level, when we look at the forestry supply chain, I maybe just want to close I have this sidebar and it's, oh. Okay. So when we look at the forestry supply chain, we have effectively a process that starts even before the nurseries, where we would be breeding trees for specific characteristics that we want out of our timber going into the future. So that in and of itself is already an interesting problem, because you're making decisions quite far, like in that for something that you'll only be harvesting like decades from now. So in a South African pine sense, we're looking at a roughly 20-year horizon between planting and harvesting. And that's actually a shortened horizon. Like in the past, it used to be longer. So due to like good forestry practice and genetic improvement, that's already shortened. But even now it's 20 years. So at that point, you have to already be making predictions about what you think the climate is going to be like, what you think markets will be interested in, what the characteristics would have to be of your trees to survive in the climate, and then also to give you the product characteristics that you need. So already before you've ever even planted a tree, you have some complex problems to solve. And then from there, once you have genetics that you're happy with and you would like to propagate and plant into your stands, we have propagation through different nurseries. So a forestry company could have either like external purchases, in which case they would probably maybe have like a hard time getting the best genetics for their problems or their requirements. Or they could have a self-managed nursery, in which case they would be like in a better position to have that like very good genetics for planting. Then once you have little trees ready for planting, they are planted in what are like called compartments, and compartments, many compartments form a plantation. And these compartments have like different characteristics, as you can imagine, depending on how warm they are, how high altitude they are, how steep they are, the kind of soil that underpin them, the rainfall that can be expected, whether or not they're in mist belts, which also affect their water availability, whether or not they like harvest water effectively, or yeah, kind of like their location would also determine how much water they are harvesting. And so I think that's kind of alluding to something we'll get to later. From there, once you've planted, you would typically have to take care of your trees for quite a while. Some of the care is intensive and some of it is less intensive. So some of your most intensive care would be taking place shortly after planting, where you would be concerned with weeding appropriately. And weeding is important because it inhibits competition. So that allows your trees to outcompete weeds if you effectively do that practice. Then you might also do pruning a few years after planting, and the pruning affects your wood properties. It also has some benefits in terms of fire risk management. And then after that, you might decide to thin your trees. So I have a few pictures later on that we'll zoom in. But thinning your trees effectively means that you reduce the number of trees that you have planted on a stand. And this also affects your, like, the timing of when you thin your trees, and then like the density to which you thin affects your tree properties in the long run as well. So once you have all of that and your trees have grown up to the appropriate age, you would be harvesting them. And after harvesting, your trees would be, generally speaking, still within your compartment, and you have to extract it to what we call roadside. And roadside is effectively what it says. So roadside means that your timber is accessible for transport at the side of the compartment. And then from there, you have transport. You can generally go straight from roadside to the mill. You might also decide to make use of a depot system where compartments are like consolidated into, or the volume from compartments get consolidated into a single pickup point, and your long haul trucks pick up from there. So this is something that you might consider, especially when you have problems with access for large timber trucks in like finicky compartments that might be either blocked by like bad weather regularly, or the roads might actually just be too windy or something similar, or too steep for those trucks to actually drive there. Then, yeah, I think from there, if you've transported your timber to your mills, it would be on a stockpile going inbound, and then it would be processed through your mills. Yeah, I think there's also like quite a few like interesting decisions to make, typically very like production centered decisions. And a lot of these decisions are maybe not so unique to forestry and forestry products per se, but then there's like quite a lot of work that also has been done in terms of optimizing like cutting patterns and cutting pattern decisions on the sawmilling side, and then also like on the pulp side, optimizing like your recipes for constructing or creating your pulp and then your subsequent products that are made out of pulp. And then from there, of course, if you completed your stock goes to outbound stockpile, and from there through like a fairly kind of expected supply chain, either via warehousing or directly to your customers. Yeah, so I think having kind of done that overview, something that's really big in forestry, and it's because of the long time horizons that you're dealing with, is the supply chain planning hierarchy. You also come across it in other supply chain domains. So I've definitely seen it in logistics as well, and also in mining. But for forestry, this is kind of fundamental to their planning processes. And I think typically people here would be familiar with it, but just at a high level, you have these different levels of planning. So typically the level that you would start your planning at would be your strategic level. And here you would be looking at a fairly long time horizon. So here we're saying about 35 years. You would often be looking at something like at least 2 rotations, which for us, as I said earlier, we're looking at least 20 years per rotation. So rotation is from planting to harvesting, and sometimes maybe you'd look at even like a slightly longer horizon. So there's like a lot of uncertainty in your strategic planning. And yeah, I think that's kind of, they tend to skip detail a bit, but then once you've kind of constructed your strategic plan, you would use that to feed into your tactical plan, which would typically take a shorter horizon and add quite like a significant amount of detail. And then from there, you would take what you've locked in your tactical plan down to your operational plan, and from there, once again, to your like online or daily planning. So I think what's also important just to note is that these plans can feed back into each other. So you might see on your tactical plan that some decisions you made within your strategic planning process are not going to work out, and you would then amend your strategic plans to account for those things that you've realized, and then feedback from strategic to tactical planning. Then I'm not going to discuss all of these, but if you are interested, I would point you to Michael Ronquist. He's a Canadian researcher, and he's done a lot of work on supply chain optimization in forestry, and he has some really nice summary papers written about it. What I would like to do today is kind of just give you this idea that there are like some really nice commonly studied problems from the forest through to sales. But what I would like to focus on would be the problems on the forestry, inbound logistics and processing side, and even at like a very high level actually. I've highlighted some problems on the processing side, but I'm actually mostly going to talk just about cutting patterns because I feel like those are quite specific to the industry. And then, yeah, I'm going to quickly mention some differences on logistics planning that we've maybe faced that you wouldn't necessarily encounter in most common logistics optimization applications. And also, I think, spend a bit of time on the forestry, like the common forestry problems, because I feel like these are very unique to the supply chain. Or maybe not that unique, but I think they are kind of the base of this discussion. So I think to start out with, a common, I think we've started there already, like if we're doing strategic planning, we're looking at fairly high or fairly long time horizons. And because of like the value of your trees like in the long run, and the fact that your decisions about what you'd be planting ultimately affect how sustainable you are, what profit you'll be making over really long like periods of time. A very common problem is that of optimizing your long-term forest management. And I think here I have two pictures, and the one picture is a continuous cover forestry operation. And here we can see that we have some trees that have grown quite tall, and then around them there are some trees that are actually just coming up, like they're still small, and there's like trees of different sizes here. And then in this picture I have plantation forestry. So in plantation forestry, you would typically be planting a site. You would want the site to be as heterogeneous as possible, and then you would be harvesting it all at the same time. And depending on the kind of forestry that you're engaging in, you would typically have different objectives, and I think it's also kind of vice versa, depending on the objectives set out by your kind of governing bodies. You would also maybe use different types of forestry. So, for example, in some countries, it is incredibly important to people that they have a nice visual impact and like a green recreational space that gets created by the forestry industry. And at that point, you would typically start using continuous cover. And in other countries, these things might not be such main objectives or such highly weighted objectives, and things like your MPV, your yield, etc. They would typically drive you towards a plantation forestry model where the heterogeneity of the trees would ultimately assist you in creating like uniform products for sawmilling or pulp or plywood, whatever you're making. Yeah, so I think as like at a high level, we have these different objectives, and I think what's just important to take into account here is that if you're using the MPV kind of calculation, this problem makes a very nice linear programming problem. And then it also still, like even in like a plantation forestry context where you maybe not so concerned with your green in recreational space and your visual impact, you might still be very, very interested in managing your risk. So you might be like interested in making sure that your pest and disease risk is mitigated, your market risk is mitigated, etc. So you might also still have some really nice multi-objective formulations in the different contexts. So I think continuing from what we're kind of trying to accomplish, an important concept for planning like your long-term harvesting and management, I'm going to call it like a schedule, would be the concept of a regime. And a regime ultimately is a combination of what you would like, you kind of state what you would like to produce. Would you be producing saw timber? Would you be producing pulp, maybe plywood, whatever you like as a main aim would like to achieve. And then given like forestry models and your knowledge of growth on certain stands, you would want to say, okay, and also then of course your intended product category, you would be selecting a species, you would be selecting a planting density. So how many trees are you going to be planting per hectare? Weeding and fertilizer prescriptions, your pruning instructions, as you said before, pruning. So I think maybe just as a quick explanation, pruning is the removal of lower hanging like branches. And these, like whether you prune and how high you prune, impacts your wood properties. And then finally, you would probably be specifying your thinnings. And I think, as we said before, the thinnings also impact your wood properties. So this is just like a little basic picture of an unthinned stand, and then a stand where several trees have been taken out, and then one where only like the largest trees have been kept. So as a general rule, a thinning operation should be removing your smaller trees or your weaker trees and keeping the stronger trees to grow. Then I think we've covered the objectives. These objectives can be quite wide-ranging. And then we've kind of also covered this important of a regime. And so now at this point, like when we're doing forest, long-term forest management, the things that you're considering are things like how well would specific regimes be suited to different site classes. And a site class is effectively, I think we've already alluded to it, we said we have compartments. A site class is a way of thinking of a grouping of compartments that have similar attributes. And this effectively makes your planning for this long time horizon a bit easier. You'd also be interested in the expected product mix that you would be able to harvest based on different regimes, based on different sites. You would be considering the available land you have, maybe possible purchases and sales that you're considering, the distance from your management areas or your plantations to the market, and then your expected cost of the regimes, and also the expected income from product sales. And then I think very importantly, you would be considering what your market constraints and expectations are. So this is also kind of very like exactly how you're going to incorporate this will be very dependent on the kind of forestry operation that you are. So an individual farmer might be looking primarily at maximizing their profit, where someone that has to feed plants like a pulp plant or a sawmilling plant would be looking at those market constraints in terms of balancing it out. Because you can't just switch on and switch off capacity on those plants very easily. So then I think we've kind of sketched the problem out, and then what remains is just to kind of look at the decisions that you typically going to be optimizing for. So the one big decision would be when to harvest your different management areas. And as I've alluded to before, you would be doing this very commonly using an ILP formulation, and you would not really be interested in doing a specific like integer solution where you know exactly what compartment you'll be harvesting. You should be looking at like what percentage of some grouping you'll be harvesting at what period in time. And then Once you've harvested something, you want to know what regime you would be planting next. And then given that, you might also like be interested in allocating your products to markets. This is, I think, a fairly standard inclusion in the problem, but it is not necessarily always included in the problem. And then I think from there, something that, like Bear's saying, is that commonly, or like, no, I don't want to say commonly, but there's a basic formulation that excludes your production and sales. And just meaning that it excludes your conversion from a log to like a lumber product. And that typically gets like a lot of critique from people within industry. There are obviously always ways of handling that, but like a common extension then becomes like adding those decision points to ensure that you have captured that detail in your model. Yeah, that's the long-term forest management. I don't know if anyone would want to ask questions up to this point. Okay. Then I think from there we proceed to tactical harvest planning. So in the previous slide we had the same picture, and these are like little compartments, and these compartments, we can kind of think of the ones that are colored in the same as having maybe similar characteristics. And as we've said before, that in our tactical or strategic harvesting step, we wouldn't have been concerned with which compartments specifically we will be harvesting. Once we get to our tactical planning phase, we do very much become interested in which exact compartment we are harvesting, and not just which percentage of some similarly grouped piece of land we are harvesting. And so I think, yeah, the time frame becomes much shorter. We're looking at like maybe a 5-year period, maybe a bit less, maybe a bit more. And the granularity is still roughly like at a year. So yeah, you'll be deciding on activities that would take place within a year. You'll be allocating specific compartments to specific years for harvesting. But the detail that you're adding is quite significant. So where before you wouldn't really have been concerned with your road network, you would have maybe accounted for that only in like a distance to a market. You would now start actually saying, but how proximate are the stands that I'm going to be harvesting in any specific year? And how many roads would I have to upgrade to facilitate this harvesting? So you would typically want to minimize the roads that need upgrading in any specific year by grouping together compartments in some sensible way. And then you would also, obviously then for the same reason, consider your road upgrade cost. What's typically very important to us is the wet and dry season access. And that's because it affects the access to compartments when it's very wet. So like very wet weather would drastically impair your ability to get to compartments. And for that reason, compartments are typically classified by their accessibility during different seasons. You would be considering your planned depots, which you wouldn't have been before. And then you would start looking quite seriously at the harvesting methods that you intend to apply. So I have some pictures at the operational planning of a few different harvesting methods, but ultimately, like, you have different harvesting capacity for different methods, and depending on things like your slope, the kind of operation that you're doing, whether you're thinning or doing a final felling, you would be considering these different methods, and you have to balance out your actual work against your capacity. And yeah, then I think what is very important at this phase as well is making sure that your harvesting requirements balance out in line with your capacity, and then also that you're balancing your wood flow to the markets. So if you have different products arising from specific compartments, you want to be sure that there's some kind of consistency going. Well, this is now if you're integrated. If you're not, then you're maybe less worried about that. But if you're an integrated company, you want to be sure that what you're sending through to your plants is going to be like stable throughout the like planning period. Then I think as a last few points around this problem, the objectives here tend to move to gross profit, maybe rather than things like pure sustainability, because you've already accounted for that in your previous plan, and your previous plan should ensure that. Where we would maybe have been looking at like a wide range of risk objectives, here you would typically not be focusing on risk objectives that much, since you should have already accounted for those, and your plan should be addressing those issues. And then I think your decision is also slightly different. So we've already talked about this. These planning problems need specific compartments. So they need to be either like a mixed integer, or they would be constraint programming formulations, or maybe meta-heuristic or heuristic formulations. Did I drop off?
Yes, I think you did.
Okay, what's the last thing I told you? I think we were here. Okay, were we on operational planning when I dropped off?
I don't think we'd started
Still
this
slide
yet.
12.
Sorry? Andre?
Slide 12.
Slide 12. Okay, so this is slide 12. We discussed
Yes.
practical. Okay, then cool. We were on slide 13. Let me just get that back. Okay, so I think, I'm not sure what I said here and what you didn't hear, but let's pretend like I haven't heard anything. So for, like I said, in the tactical kind of phase, there's different modes of harvesting, and these, you tend to choose them on like based on different criteria. There's cost implications, there's productivity implications, but then there's also like a suitability to your site. So until I think cinema reasonably recently, mechanical harvesting was predominantly well suited to flatter sites. It is becoming more and more possible to harvest on steeper sites, and motor manual harvesting you can use anywhere, and it doesn't have massive capital outlay, but it also tends to have slower productivity, or lower productivity. And then if you, I think we've mentioned this already, like once you've harvested, you've only really put the tree still in the compartment. You need to then get the tree out of the compartment. And yeah, there are so many options for doing that. I was looking at trying to get like an infographic, and it was just too many actual things to even discuss. But they are, once again, like kind of on the extreme ends, maybe not the most extreme ends. You could use something like a forwarder to get your timber out of the field and then onto the side of the road. And a forwarder is typically also quite well suited to flatter terrain, not very, very steep terrain, but it's fast. Like you can take out quite a lot of logs at the time, and you can do it with only this one piece of equipment. On a more extreme end, you would have on the extreme, like slower end. It's not the slowest maybe, but you have cable yarding, and it's a bit difficult finding a nice picture. But cable yarding effectively has this range that you set up on the side of your compartment, and it's used for steeper compartments where you can't really necessarily use something like a forwarder, and you would be pulling out trees using these cables, and you can only pull out like a few trees at a time. It's very, very slow going. It's quite dangerous. People have to be very careful. So because of that, it's slower to ensure that they don't have unnecessary accidents. And yeah, you have like these extreme spectrums. And why this matters is that your decisions on what equipment you use will like drastically impact your productivity. And well, as we've kind of already alluded to, you don't necessarily have unlimited capacity of any one type of equipment. So you have to be quite clever about how you assign your equipment to compartments in the short term. So this decision, on which harvesting teams to assign, and by teams, maybe methods would be more accurate, but which harvesting methods to assign to your compartments, given your team capacity, is kind of one of the primary decisions that you're making when you do optimizing like harvest planning. And like very similar to the tactical plan, you would be considering similar things, but your decisions have kind of changed, if that makes sense. And I think other than that, some interesting variations. This one is also only going to make a bit more sense once we go to the next slide. But you can extend this problem through production and your cutting pattern decisions there to sales, but you can also extend it back a bit.
And we lost connection again. And others on the call hear me?
Hi, yes, we've
Yes.
near Esmarie, we've just load shedding problems. I think it should come back soon. Sorry.
Give her a minute.
Yes, can you hear me?
I can hear you.
Thanks. I just wanted to check if my mic was working. Does anyone want to try and carry on with the forestry talk?
Oh, yeah, she's just joining again.
Great.
I'm so sorry. I think you get bad days in Solby in terms of internet, and today seems to be a bad day.
Sorry, Esmarie.
No worries, Esmarie. The beauty of recording it means that we can just edit these bits out.
Okay. Back to uh,
Esmarie, you're a bit choppy. Is everyone else experiencing that?
okay, can you guys hear me? Because I think we've kind of touched on bucking.
Are you there, Esmarie?
Nope. Yeah, challenges of scheduling the talk at the right time for load shedding.
Yeah.
Okay, I've changed the connection to one of the other internet options that work. So
That sounds better.
okay, let's continue. Go from this slide. We have, yeah, I think we've finished the operational planning problem. So, okay, bucking is like it's a really cool problem in a lot of ways. I think it's what I kind of like about it is that it's such a nice little optimization problem in theory, and in practice, it's also actually quite hard to implement. I think technology has made it more and more possible to use optimization logic in practice, but to a large extent, these people were probably bucking decades ago, and the kind of conditions in which they're bucking is not necessarily all that different today. It depends on the operation, but it's in field. The terrain is uneven. People wouldn't have a handsaw, but it's not easy conditions to be working in. Bucking is also interesting because it's once you've made all these other decisions, right? So you've made decisions about what you're going to be growing for a really long time. You've grown trees for 25 years, maybe 20 years if you're lucky, and you've had to look after those trees, you've had to maintain them. You then had to kind of decide like what kind of harvesting team to send in to harvest them. You've made like all these decisions and you've made all these investments, and then you decide how you're going to cut up the tree. And this first cut very much kind of determines what you'll be able to do on your further breakdowns going through your sawmill. And there's actually just so much opportunity to lose value at this seemingly very simple step. You're just cross-cutting a tree. So I really find this like a fascinating problem. Just for that, kind of it blows my mind how, yeah, that's like this very old problem, and it has some really nice operations research solutions that have been developed over decades. Yeah. So I think an important part of the bucking process is something called a buck spec. And what the buck spec typically would just show you, this is kind of like a sample of maybe like a mix eucalyptus buck spec. And you can cut different products. And the different products you cut would have different specifications in terms of the diameter, the thin end, and then the length. And then also kind of in what length increments they exist. So some products, like you'll see this pulp product, only exist at a 2.4 meter. But then these products, the building and fencing poles, can exist from a 1.8 to a 12 meter pole. And then yeah, you would hopefully be considering your price in your buck spec, but it would depend on how you're going to be proceeding from here. So this is kind of like a little just fun exercise I did at one point. And I kind of was just looking at this again, and that's why I'm saying, like, hopefully we are considering price per cube. So heuristically, as a human, like a common way that you might be bucking would be using like some rough greedy algorithm. You also get software applications that use greedy algorithms. A nice kind of exact solution is via the dynamic program, or via dynamic programming. There's also shortest path formulations. And I think what's just interesting is that the greedy algorithm, if you do your prioritization correctly, performs fairly well. But if you don't do your prioritization correctly, so if you don't effectively consider the price per cube, you would actually wind up with reasonably poor solutions in the long run. So compared to what you could have been gaining in terms of an optimal decision for your log. So then I think what's important to say as well is that the bucking problem exists on a lot of different levels. So it exists as a single tree bucking problem, and this you would be using to understand, like we've alluded to earlier, like you would want to know what products you'd be getting out in the long run. So being able to model a tree and then buck it to some product spec allows you to get that information for planning and planning across your whole supply chain. It also would exist as a kind of policy-based decision across a stand. So you might want to say, on this stand, these are the rules I'm going to be following to buck for maybe the stand I'm going to be bucking on a more like bulb focused spec, but in another stand I might be bucking towards a more sort number focused spec. And there's an optimization problem that you can apply there. And then I think what I've alluded to is that technology has actually made it like possible to use algorithms to optimize bucking in the form of harvesting, mechanical harvesters. So most mechanical harvesters today would allow you to use some form of optimization algorithm to buck the tree. And then some like a significant amount of research has also been conducted to feed back your individual cuts that you're making per stem into your demand, like maybe like a site level demand like, I don't know how to explain this. So you might have like a target for the site in terms of the production you want to get out for different log classes, and your machine would then effectively be like tracking what you have cut already and then changing its decision on what to cut next based on like a prediction that it can form on what still might be coming. So it's actually like, if you take that compared to this picture on the left, things have actually come like a very long way, and they will probably get even more refined in the near future. Then I think I'm really worried about time, so I almost don't even want to look at this. But I think something that we've realized recently, and it's maybe something that's easy to forget, is the forestry like kind of logistics problem, like the inbound logistics problem, has like a few interesting features. So if we look at my little depiction of different roadside sites that we can pick up timber from, and we imagine that these like little bits of logs are different products that are better suited to different plants, and we also then kind of notice that there's different distances. This is very similar to a lot of logistics optimization problems, but something that we've realized talking to kind of possible suppliers is that there are like a few key differences between what we would see as the logistics optimization problem in forestry and what kind of is like a standard, maybe more like outbound logistics application that a lot of software gets developed for. And so I think one of the key things that like becomes like an additional question that you would typically already have answered by the time you do like an outbound logistics type solution or use that is, what products should be delivered to which markets. And this, effectively adds like a layer of complexity to the physical like truck scheduling problem. Then another thing that we have that's a bit different from the norm would be that we have a pickup and drop-off problem. And to know where you can actually pick things up, you have to decide where your loaders are going to be stationed. And so this can be like a pre-processing step, but it also kind of has to be handled in a different way from maybe a situation where you already know where you will be going, and you have to decide the best way of going there, like most efficiently. Yeah, and then I think this is kind of what you would be used to in other domains would be like, how should the trucks be scheduled? That would be like more the default way of looking at that problem. So I just wanted to touch on that quickly. Then I think very similar to bucking, which you get to use across all your decisions on the forestry side, cutting pattern simulation and optimization is another field where people have done a lot of work over the years. And I actually won't even discuss all the problems that it gets applied in, but it feels like you can't have a talk about OR and forestry and the product supply chain without looking at cutting pattern simulation. So I think we've already had this picture on the bucking side. And yeah, your first cut would typically determine the size of your log, and then it's going to give you the diameter that you would be able to then cut into different products later on. Yeah, I think this is a depiction of the resulting products coming out of, so this is simulation software or cutting pattern simulation software. This is developed by Harco Systems. We also have a freeware South African version called SimSaw, and these software applications effectively allow users to understand how different cutting patterns would perform on logs with different characteristics. So that information is very valuable in terms of deciding on all kinds of things. So it might help you decide what technology to acquire. If you look at the logs coming out of your forest or what you expect to be coming out of your forest, you can then use cutting pattern simulation to determine what kind of possible new technology would be well suited to those logs, and would allow you to maximize value out of those logs. Similarly, if you already have existing technology, you might be interested in determining cutting pattern policies for your production planning purposes. You could also, so that would maybe be in a world where you set your policies and separate that slightly from the production planning. So you might say, these types of logs we're going to always cut against this pattern. But what you can also do is you can also do production planning on like a more kind of granular decision in terms of the cutting patterns you apply. And then you can also use this information in plant to customer allocations. So you might want to specify a plant on some operational or tactical level that supplies a specific customer. And that customer's mix might be better suited or worse suited to some plants. Or maybe you want to do that on an order level and the order is better suited or like worse suited to some plants, depending on the technology that's running in that plant. So yeah, I think that's maybe an interesting or important point to mention is how you can cut your logs is actually very much determined by the technology that you invest in the long run. And they offer you options for different cutting patterns, which result in different yields and then ultimately also in different values per stem or per log that you're cutting. Yeah, I think we've kind of mentioned this already, so it would kind of depend on the exact problem that you are trying to solve, but you would be considering your raw material characteristics. So how does your logs look in terms of their shape? Are they very skew? Are they very tapered? You would want to consider how many of what kind of log you're getting, and then also your cost. Then depending once again on the kind of problem that you're trying to solve, you might look at your market constraints, your market prices, and then you might also look at your sales strategy. And if you have already made a technology decision, you would consider what technology you have available and your capacities. So, but this is kind of like in a very abstract sense across how like the whole production planning domain. It's just kind of the applications of the cutting pattern simulation. Yeah, then I really like this case study. So I thought like, it's just a nice bit of reading if someone's interested. It's a very short paper. So in 1998, Bosques Arauco, I don't know if I'm pronouncing that correctly, they won the Franz Edelman Award, which is obviously a very, very high honor in operations research. And they won it for a collaboration between themselves, other Chilean forestry companies, and the University of Chile. So, okay, Bosques Arauco is a very large, I think predominantly pulp company in Chile. And they won this for a series of operations research applications that they implemented across these companies. And the applications that they implemented at that time yielded them about like a $20 million per annum saving throughout the companies against the combined sales of about 1 billion per annum. So that's a 2% saving per year, which is that's quite crazy on your sales. And I think just now we've kind of looked at a lot of these applications, and I think hopefully they would make sense given what we've spoken about. The 5 systems that they implemented, the one was called ASICAM, and it's a vehicle scheduling application. And like I've kind of mentioned, ASICAM would kind of consider these little strange considerations that are a bit unique to, or maybe not unique to forestry specifically, but maybe particular to forestry. And then they also did a short-term harvesting solution called Opticord. And what's quite cool about Opticord is that it takes the short-term harvesting decisions. And as I've kind of mentioned, they made the decision to incorporate the bucking decision within the short-term harvesting decision making. And it's not that they're doing the exact buck per tree, but they're deciding like on a bucking policy for a stand. And they initially didn't do the bucking as part of the model. And then after they incorporated it, that gave them like 3 to 6% additional gain on the existing optimized solution. So I think that's quite a significant gain for adding that decision. Then they also did a machine location and road design solution. And this we haven't spoken about specifically, but it is kind of related to what we were talking about. Like if we, it's related to the tactical planning with the road design, and then, but they actually did this at a more operational level. And then they were considering if you have something like a cable yarder, where in your, where in your compartment, or should you actually be locating this for your like optimal road design and access, and then ultimately minimizing your cost in terms of those operational decisions. And then they also had the tactical forestry planning solution, and we've spoken about what would typically be involved there. And they had a strategic planning solution. And they said like at the end of the article, they effectively say that they've had the best uptake for their operational solutions. And they believe in part that it's probably because there were already existing solutions to these 2 other problems. So if you're interested, it's a 1999 article on the use of OR systems in the Chilean forest industries. Then I think I'm kind of worried about time, but I'm just going to run through this. McKinsey and Company did quite like a nice summary of where forestry, or they expect forestry to go in the future. And a lot of what people expect, or like I think what is expected not just by McKinsey, but where forestry will be going is this concept of precision forestry, meaning that decisions will be made on much more specific data than in the past, using technology to gather information much faster than before, and a higher quality, more accurate information than before. And so what I mean by that is, very often at the moment, to gain the information or the inputs to some of your planning models, you would, maybe not even at the moment, like things have already started changing, but the only way that you could have gained that information in the past would have been with very extended trials that take years to run. So if you wanted to understand, I'm trying to think of an example, but site performance, you would be doing that only typically, or not only, but like primarily through trials. And then where we're going now is that they've been doing like a lot of research on like the pine genome, or even also the eucalyptus genome. That's actually apparently simpler than the pine genome.
Have we lost Esmarie again?
Sounds like it. It's the last slide, I think, so almost there.
This is crazy. I'm so sorry. Where did you lose me?
Just 20 seconds ago.
Let me just finish. I'm so nearly done. I'm so sorry. Okay. All right. So did you hear me speaking about LIDAR? Yes. Okay. And then I think what we've also kind of discussed is mechanical harvesting and the additional information that you're gaining, and then also the optimization and opportunities that exist with that technology being in field. Then, yeah, I think this is just kind of adding to this concept of making decisions on more precise information. These are like pictures of subcompartments. And that's effectively like little pieces of compartments where you have very specific information relating to that piece of a compartment. And you can then start using that information to gain more accurate predictions on the yield that will result from these portions of the compartment, and ultimately from your compartment and your whole biological asset. And that kind of information will obviously then feed back into your planning models and give you like a high level of accuracy in terms of those models. So that's quite exciting. Yeah, so the same kind of McKinsey article, I would also recommend reading this article, talks about things that they expect, or promising things that they see happening. And I've kind of just picked out a few things that relate to operations research. So I think we've looked at the subcompartments already. So effectively, one of the big things that would influence how we can use information to make like better planning decisions would be the kind of level of detail that is expected to become available in terms of, your site quality, like being like much more specific and much more granular than before. I think we've already discussed the mechanization. I've already kind of talked about the genetic improvements that will kind of give, like a very different angle to the decision making that you have both on your tree breeding, but also on your long-term planning decisions. And then we've spoken about digital inventory in terms of LiDAR. That's mechanized. Oh, that was mechanized horticulture. And then I think something that's maybe like a bit, it's not that maybe advanced or new, but things like apps and iPads and phones, or not even iPads. The ability to kind of gain information faster and make it easy for people to just submit information about what's happening in field also kind of feeds into better planning models, in that if it's easy for someone to note an issue on a road, maybe via an app, that issue can then feed into your roads planning in a way that it maybe would have been missed if someone had to like go to an office and submit the information via some more traditional method. Like that's maybe a small example, but there are like lots of little examples where having someone be able to give you information easily is going to improve the level or the type of information you have available for planning decisions. And then, yeah, I think the last thing to maybe mention, I've kind of thought I would mention it here, is it's also like a precision forestry thing, but there's like a growing understanding of the interactions between your sites and your wood properties. And there's quite like a lot of, well, there's an exciting kind of space where you would be able to use this more detailed information about what wood properties to expect on different sites in your planning models. So yeah, I don't know of like a good example that I can share, but sites with like maybe different slopes would typically have different sweep, or they would different have sweep characteristics, and then they might also have different, their rings are shaped differently, and that affects the sawing of the trees. So the better like people understand those things, and the more like the better those things can be modeled and then used for prediction in terms of yield, the more refined ultimately your supply chain planning tools become. Yeah, that's it. That's me. I'm sorry for all the interruptions. Do you have any questions or comments?
Thank you, Esmarie. And sorry for the interruptions from your side too. Cool. There's a question in the chat. I don't know if you want to read it or I should read it out for you. Or I mean, for the recording, let me read it. Other than cutting pattern software, do you make use of specific commercial optimization products for the various planning optimization problems? Are they bespoke, developed applications or configured applications?
Okay, that's a good question. So I don't really want to talk about like our company. So I think what I will say is where it makes sense, we would use these, but no, I don't really want to talk about the company. Sorry. A lot of people do use, so I can say like in the abstract, right? Like a lot of companies do use specific commercial products. I'm sure some companies also do bespoke developments. But I don't really, like I've kind of tried to keep this agnostic as far as I could. Yeah. I'm sorry, that's a vague answer, but that's my answer.
David?
Hi, thanks, Jess. Thanks, Esmarie. That was a great talk. I mean, I think there's enough there to almost think about maybe having a panel discussion with people working in the sort of natural resources domains, because there's a lot of interesting difficulties in the decisions that have to be made across large timescales as well. On the point of the strategic stuff around like the 35 to 20 year planning, how much do you consider sort of different climate change models when you
Oh, I think I've dropped off again.
I can hear you. I
Okay. Okay, so I think DC's question was, I think maybe DC dropped off there. So DC's question was about considering climate change models in the strategic planning. So I think the answer there is to a fairly large extent. especially given like the tree breeding decisions that go, like that happen before you even plant the trees. Like quite a lot of climate information goes into those tree breeding decisions, and those tree breeding decisions then feed into your strategic plan ultimately. So it's kind of like almost a step, or it's I guess at the same level, but on your strategic plan planning level, like you would already kind of have this tree breeding decision, and the tree breeding decision would have accounted for your climate change. Then from there that would give you the species that you plan to plant and some prediction of how you expect those species to behave on sites with different climates. And yeah, I don't know if that answers your question, but effectively that gets considered quite thoroughly, but almost a step before that specific optimization model, if that makes sense.
Yeah, that's great. Thanks. Thanks, Esmarie.
Okay.
I thought one interesting thing, I'm not sure how well I'm coming across, but you mentioned the Chilean company winning the 1998 Edelman Award. So they also won last year. So they won the 22 Edelman Award, the Chilean government, for their response to COVID. So
Oh, wow.
the Chileans seem to be punching above their weight.
That's very cool. I think they have, it sounds like a really nice, I don't know if it was the same department, but it sounds like at the University of Chile, they do some really cool work and like practical work. I don't know if they were involved with a second award as well, but
yeah, they may well have been.
That would be cool to know, because I think they actually have like a fairly good relationship with industry, and I think that's helping them to accomplish those things. But that's just a guess. Like, I don't know either. Yeah.
The question, sorry, around the that McKinsey report, is there work being done in trying to sort of almost create this concept of digital twins for the forestry industry?
Yeah, I wouldn't be able to answer you on that. Someone else was talking about digital twins the other day, and then I was kind of looking at it in terms of production. I'm really not sure about forestry per se. I really can't answer you.
Okay.
Cool, Andre.
Thanks. Yes, Esmarie, well, leading up to harvesting, obviously, I assume the trees' growth and characteristics are being tracked over time. In what granularity is that happening? And is there really gains of doing it in a more granular level, like maybe tracking every separate tree or something like that?
Okay. Yeah, so Andre, you're actually asking, but it's my talk. You're asking a question for someone else who's on this talk. But they do track it over time. The way that they track it at the moment, or classically maybe, would be, so some like companies already maybe moved across to some other methods, but a classical way of tracking would be like a sampling methodology, where you would at different periods throughout the growth cycle do a sample, and then before a specific activity, so before you do thinning or before you do harvesting, you do a specific sample to understand what you would be expecting to get out of that stand. And there's like quite a lot of error that can creep into this way of measuring your trees or tracking your trees. There's a sampling error, and then there's your measurements. You can have a calibration error on your machines. It's possible to just hold your calipers like a little bit too high or a little bit too low, and you would then get a measurement error for that reason. And what else is like a problem? Yeah, then from there, you use those data points in prediction models. And if they have errors, then those like errors would tend to propagate into your predictions. So the expectation is that there's quite a lot of value in being able to get better granularity on those measurements. just because you would be expected to reduce some of your errors significantly. Yeah. Does that answer your question?
Oh, yes, thanks.
Okay.
I was just thinking back to that story about Melbourne that gave each of the 70,000 trees in the city an email address or something like that. So I'm sure you are dealing with millions and millions of trees.
I would actually be curious to know how many trees we have. That's an interesting question. That's a question you could answer very quickly with LIDAR. Like, yeah. I think we have an estimate of how many trees we have, but I don't know what that estimate is. Like, we know the volume, but I don't know how it translates to physical trees standing.
Okay.
About if you take a company like our size, about 60,000 hectares, you're looking at somewhere like 50 million trees.
Wow.
On the land only, but that's like a medium-sized company.
Okay, thanks, Carol.
Are there any other questions? Doesn't look like it.
There's one in the chat.
Oh, have I missed it?
I think you
Has-
just came in
oh.
now.
Cool. With David mentioning digital twins, I think agent-based simulation might be a good tool to evaluate strategic decisions with variation of key strategic input considerations. Question mark.
Yeah. No, I mean, I think that's also like kind of a comment. I think it's a fair comment. I think you can definitely use agent-based simulation. You can also consider other simulation. And people surely have. Like, I'm not in the academic space, so I'm not reading all the articles, but I would put money on people considering these things, and especially these well-studied problems, because just because they're like very universal to the forestry industry, and across the globe there are universities researching these problems. So I think your agent-based simulation would be a good tool. I think even they are maybe not for the strategic decisions, but on the more tactical and maybe even more operational decisions, something like discrete event simulation would also be a useful tool. And then even just kind of more stochastic approaches to your decision making at those levels are also good things to consider. You know, even if it's not simulation approaches necessarily. Yeah, I hope that answers your question. Okay. Any other
Seems like it.
question? No. All right. Thanks, everyone. I was quite nervous, but it's been quite fun. Yeah. Thank
So
you
much, Esmarie. This is really great. Yeah, thanks.
All right. Thanks, everyone.
Thanks, Esmarie. That was super. Really enjoyed it.
Okay. Have a nice evening.
Thank you, everyone. Go well.
Yeah, thanks.
Thanks, everyone.
Yes.